work on our chapter, our section 1.10. And as always, whenever we start a new section or a new chapter, we start with the learning targets. And the learning target or the goal for today is to solve equations by using the division and multiplication properties of equality. Well, let's get that definition in mind, what we mean when we say that. Really, when you say we're dividing each side of an equation by the same number, the two sides remain equal. The two sides remain equal. One complication is that we have to keep this to be a non-zero divisor. If we cannot divide anything by zero, it becomes an undefined term. It goes towards infinity, but it's not a defined term that we can work with. So a couple of examples here. I've got my teeter-totter, my seesaw, and I've got it in balance because it says they're equal, and of course 12 is equal to 12. Well, whatever I do to this side, I also have to do to this side. So if I'm going to divide this side by 4, I've also got to divide this side by 4 to keep my balance. You can see 12 divided by 4 is equal to 12 divided by 4, and when I do the math, of course, I get 3 is equal to 3. Well, the same idea holds over here. This is my balance. This is my seesaw that's in balance. All right, I've got 5x is equal to a negative 60. Well, I want to know what x is just all by itself, so I'm going to divide this side by 5, and of course I have to divide the other side by 5. These will cancel out because they're inverses of each other, leaving just x. And negative 60 divided by 5, I actually do the division, and I get 12, but since the signs are different, I have to take a negative sign. It must be a negative sign, so the answer is x is equal to a negative 12. All right, let's do an example here. We're going to solve 7z is equal to a negative 49. 7z is equal to negative 49. I'm going to divide both sides by 7. So that's going to give me z then is equal to negative 49 divided by 7. Uh, 7 divided into 49 will go 7 times, but it's got to be a negative 7 because I've got a mixed set of signs there. Looking at the one here at the bottom, I'm going to divide both sides by 8. These are inverses of each other, so they simply cancel out. I'm left with a is equal to 8 will go into a negative 64 8 times, but since these signs are different, I have to have it as a negative 8 is my answer. So the answer is negative 8. A is equal to negative 8. This one, same kind of rule, but this time we're dealing with multiplication. If I multiply each side of an equation by the same number, the two sides remain equal. So to do it with numbers here, we can say 5 is equal to 5. That's true. If we multiply both sides by negative 4, we maintain its equality, maintain the balance of the seesaw, the teeter-totter, and we say negative 20 is equal to negative 20. Here's a problem where we might use it. We say x divided by 2 is equal to 8. Well, I'm going to multiply both sides by 2. Both sides by 2. These are inverses of each other, so they're going to cancel out, leaving me just with the x. And x is going to be equal to 8 times 2, or 16. There we go. A divided by 9 is equal to negative 6. Well, in this case, it looks like I want to do multiplication because I want to have the additive, or I want to do the inverse property of dividing by 9. So I'm going to multiply both sides by 9. All right, these are inverses of each other, so I get A is equal to a negative 6 times 9. Well, if I multiply 6 times 9, I get 54. And since they are not the same sign, it has to be negative. So A is equal to a negative 54. The next one down, I want to multiply by 5, both sides by 5 to maintain the equality. These are inverse operations of each other, so they cancel out, leaving just x, and x is equal to 5 times a negative 10, which is 50, but again, since they're mixed signs, it is a negative 50. Here's a word problem. It says the chain was a unit of measure around the year of 1600. One chain equals 66 feet. One chain equals 66 feet. If the south side of a property was 330 feet long, how many chains long is it? Well, 330 feet is equal to the number of chains, which I'll call C, times 66, because each chain, one chain is equal to 66 feet. So I've got to solve this equation. 330 feet is equal to 66C. I'm going to divide both sides by 66 to find out how many chains there are. These two are inverses of each other, so they cancel each other out. 330 divided by 66 looks like it goes 5 times. 5 times 6 is 30. Carry the 3. 33 goes 5 times. So C is equal to 5. So 5 chains is the length of that field. A horse is measured in hands. One hand equals about 4 inches. If a horse measures 60 inches, how many hands is it? Well, it's very similar to the last problem. I'm going to say 60 inches is equal to the number of hands times 4 inches. All right, so that becomes my equation. I want to divide here because I'm multiplying here, so I want to divide so I have the inverse of each other. These two are inverses, so they cancel each other out. H then is equal to 60 divided by 4, and that's 15. So a horse that is 60 inches tall is 15 hands tall.